We are group 5A, and we will be presenting on problem 10.
We're going to take the internal shear force first, and it's going to be the applied load P over 2 because there's going to be two areas of shear force. That will give us 75 kip. And then after that, we are going to follow it with the shear stress, which is the shear force over the area, which will be 75 kip over pi times 1¼ inch over 2 squared, which will give us 61.12 KSI.
From our given diagram, we can find our shear strain, and we can also use both of the slopes of the lines to find our shear recovery and shear permanent. So as you can see, there's a clear slope for the elastic and plastic deformation. And we have two given values of 50 KSI at 0.005 radians and 75 KSI at 0.05 radians. So we can calculate the shear strain at our shear stress of 61.12 by using the similar triangles rule. So we know the slope of our line using the points given 50 and 75, and we can plug all those values in to find our unknown shear strain value of 0.02501 radians.
So after we have figured out the value for the shear stress and strain, we can use that to calculate the shear modulus G, which is similar to the elastic modulus, which is just shear stress over shear strain. And the value is calculated by 10 to the 4th KSI.
So once we find the shear modulus, we're then able to solve for the shear strain for recovery, which is given as the value we found back in the very first part, which is the shear stress over the shear modulus. So it'll be 61.12 KSI over 10 to the 4th KSI, which then results as 6.112 times 10 to the negative 3rd radians.
Finally, the permanent set of the shear strain after the force is removed. Gamma permanent is equal to gamma minus gamma sub r is equal to 0.0189 radians.